Okay, last decision tree question. As you can see, this was made up before the election. Imagine that you operate a factory that makes elephant statues. You can make 10,000 statues per year, but you have the option of adding additional capacity so that you can make 5,000 additional statues for a total of 15,000. If Donald Trump wins the election, then you sell a lot of elephant statues because it's the Republican symbol. By a lot, I mean your entire production run. However, if somebody else wins, then you will only be able to sell 7,000 elephant statues. If each elephant statue makes $100 in profit, and the probability of the Trump victory is 20%, how much is the option of additional capacity work? Hint, this means the maximum amount you'd be willing to pay for the additional capacity. So let's set up the decision tree. First decision is add capacity, or keep same size. All right, then the voters get to decide who's going to win. Trump could win. Once again, this was before the election. I made up this question. We already know what the outcome is, but Trump can win or someone else. Of course, I guess it'll be good for next election too, right? Not Trump. Okay, 20% chance of Trump winning. Okay, so if we add capacity and Trump wins, then we get to sell all of our run, which is 15,000 at $100. So 15,000 times 100 is 15000. So 1 million. If on the other hand, Trump doesn't win, then you only sell 7,000, which is $700,000 worth of elephants. On the other hand, if you don't add the capacity, you still have the same $700,000 worth of elephants here, but you only get to sell 10,000 here because you didn't add any capacity, and that's all you can make. Okay, so here's the decision tree. Now the question is, what is the question? Oh, how much is this is this extra capacity worth? So assuming to add capacity is going to cost something, we're going to have here minus C and minus C, right? The cost of adding the capacity. So how much would that C have to be? What's the maximum amount that C could be for us to want to do that? Okay, so the expected value here is 1,500,000 minus C, and you have a 20% chance of getting that, plus an 80% chance of getting 700,000 minus the cost of the capacity. So that's what you expect to get there. Down here, you got just a straight up, because you're not spending any additional money, 20% chance of 1 million, plus an 80% chance of 700,000. So let's calculate this one first. This is 200,000. 8 times 7 is 56. 56 plus 2 is 76000. So if you don't have the extra capacity, you expect to make this much money. So you want this number to be greater than 760. Okay, so if the capacity costs any more than that, you would say, I'm going to do this. Okay, so let's do this guy here. So we're going to have 0.2, that's not what I want to do. I have 0.2 times 1.5, which is that's 2, oops, 1.5.2, that's 300,000 minus 0.2 C plus 8 times 7 is 560 minus 0.8 C is greater than 760,000. That's a really big comma. Okay. So put these two together, you get 860,000 minus C minus 2C minus 8C is greater than 760,000. I'm going to take this one to this side and that one to that side. So I'm going to have 100,000 is greater than C. Or if you read it the other way, C is less than 100,000. So if the additional capacity costs less than $100,000, you should add the capacity. Of course, now that we know who won, you should have had the capacity, but we didn't know at the time, but I made up the question. All right, so those are all of the questions for now. Thank you.